So I think I'm going to start now. So good morning, everyone. So welcome to the presentation for the power plant CDI modules. So before I start, so let me just introduce myself. My name is Pan. I've been with the team for the last 10 plus over years. And at the same time, together with me is Ted Kim. He is based in South Korea and he looks after all of the CDI market in the North Korea side. He is a very experienced guy and he also worked in the team for a very long time already. So a few housekeeping things, is to let you know, you've just got to make sure that that you can hear me. If there's a problem, you can try and restart on the webinar, and then if it's not going to work, you can always dial it. If you have any questions, you can always try to submit it through the webinar control panel through the messaging, and then Ted Kim is going to take note of it. We will answer it at the end of the presentation. If we don't get to your question, we will respond it through email. All right, at the end of the presentation, a copy of it and the recording, it will be emailed to you guys. All right, so these are the topics that we are going to cover today. So the first thing is about us, the product history, and then after that is on the basics of CDI module. After that, we will talk about the markets and application on power generation. We will also try to cover on all of our products. After that, we will compare on the mixed bed DI module versus the CDI module. We will also touch a bit on our warranty and sort of services and resources. And last but not the least, we will also cover all of the questions that at the end of the presentation. So about us, Evoqua is a public traded company in the New York Stock Exchange. And for us, IMPO, it is the product under the Evoqua Water Technologies. All of these products is being manufactured in Tewksbury, that's in the USA. We are very focused on CDI sales and distribution through the OEMs. We also have a research team that is in Lowell, that is close by to Tewksbury, and also in Singapore. And in all, we have more than 30 years of experience in CDI modules, and we teach people how to design them correctly, and after that, how to do troubleshooting and also the maintenance. So for EDI history, it started a long time ago, but it really began in 1987, where it's being first commercialized by the Millipore. At the later part of the slides, we will cover more on the products, but for this slide is to just let you know the key milestone that we have. We had our first CDI for the boiler feed in 1993. So in the very early days, there is only the resins in the product compartments. There is no resin in the concentrate compartment, so there is a need to recirculate the brine. In 1995, we introduced the resins in all compartments in the product and in the concentrate. And by doing that, there is no need for you to recirculate the brine anymore. In 1997, we made the first commercialized thick cell CDI. So this allows us to make modules at a higher flow at a lower cost. Okay, in 2004, we made a new CDI module. It's called the VNX module, and this is the high flow series of about 50 GPM of a flow rate. So throughout all this whole period, it is still the same team that is researching all these new products for you, but we went through a few companies from the US Filter to Veolia to Siemens, and then now we're under Evoqua. So in the very early days, all of the water system is based on the resins. Okay, so instead of the RO, there is the cat iron and also the anion bed, and then after that is followed by the mixed bed DI. So in the 1980s, where there is a need to reduce more of the TOC, so there comes the RO system, and then the cat iron and then the anion bed, it was taken away, and it also reduces a lot of the chemical usage in the water system. Since the 2000s, CDI started to come into the picture, okay, and then there is a combination of the RO and the CDI. It has completely eliminated the need of the regeneration chemicals, and also it brought in a lot of other benefits too. So this is a timeline of our products. So basically the main driver for all these new products is the need to produce a higher volume of water at a lower cost and also a better water quality. So in 2001, we had our first LX series, where there is all of the resins in the concentrate and in the product. In 2004, we made a higher flow module. It's called the VNX Modules. And at the same time, we also made the hot water modules for the pharmaceutical plants. In 2007, we improved the performance of our VNX modules to make the E and the EX modules that is specifically for the microelectronics, for super high recovery and much higher silica and boron removal. In 2009, we introduced the VNX HH module. It's called the high hardness module. So it's mainly for poorer feed water of up to 1 to 2 ppm of the hardness. In 2010, we came up with the generation 2 power controllers and then also the Lab XT for small flow rate operations. In 2013, we increased our nominal flow rate of our standard VNXs from 50 GPM to 55 GPM. So at the same footprint. There is also the thin cell CDI-T that is for even poorer feed water of up to 4 ppm of the hardness. In 2014, we modified the resin in the VNX modules, and it is now the EP modules. So the EP modules, it stands for Enhanced Performance. In 2016, 2017, we came up with the generation 3 power controllers. At the time, there is no there is no more of a transformer that is needed. In 2018, we increased the flow rate of our VNX modules from 55 GPM to 62.5 GPM. So at all this time, all the footprint is still the same. So let's touch on the basics of CDI technology. So in water, there is a lot of ions. So for example, there is a sodium and a chloride in the water. So for the sodium, it is the cation ion, and then for the chloride, it is the anion. So when you apply a DC current across the electrodes, the sodium, that is the cation ion, it will move towards the cathode. So opposite charges attract. For the chloride, that is the anion, it will move towards the anode. So after that, we try to add in a few membrane sheets in between the electrodes, and it's going to form the process electrodialysis. All these membranes, it has a fixed charge and is also selectively permeable. For the anion membrane, it is positively charged. Okay, it only allows anion to pass through. For cation ion, it is negative charge, so it can only allow cation ion to pass through. So all these membranes are impermeable to water. okay, and then the water is going to flow past the membranes, but it will not flow through. Only the ions is going to diffuse through the water trapped in the membrane. So in the process, all the salts is being transferred out from the product stream into the reject stream. So for the ED process, it is not effective at low TDS, so it's mainly being used to desalt a high TDS water that is like brackish water. And for the ED process, it does not take away any of the weak species, it's like the silica and the boron and the carbon dioxide. So after that, we add in the resins, okay, into the ED process, and it forms the CDI. It's going to form the CDI modules. So all these resins is very conductive. It needs a special cell to contain it. And then the resins is also many times it's more conductive than a solution. So with all these resins, it also allow the removal of the weak species is like silica and the boron and the CO2 too. So this picture is going to illustrate you a 3-cell CDI module. As the water, it flows from top down. The cation is going to move towards the cathode, and then for the anion, it's going to move towards the anode. So all these membranes is going to serve as a barrier such that all of the ions, that is the sodium and the chloride, it will be trapped in the reject stream. So at the same time as the water is flowing down the module, there is also a water splitting process. So if you see the diagram, all of the H2O is going to split up into H plus and OH minus. So it's going to regenerate all of the resins at the same time. So it's consistent performance. So if the feed is about 5 microsiemens, that is from the 2-pass RO, on the reject side, it would be typically about 10 times the concentration. That is about 50 microsiemens. And then on the product side, it will be all of the clean water that is going to be 10 mega ohms or at least 0.1 microsiemens at least. So when we put all this in a module, okay, that is going to form the VNX module and also the LX module. So all of these compartments and the membranes are being placed alternating. And then if you want to have a bigger module, all you need to do is to add in more cells and also membranes too, okay? But if you add in more, there is going to be a much higher power consumption. So markets and applications. So the use of the CDI module, it continues to grow at this stage, okay? So the graph on the right is going to show you the cost per GPM timeline. So for us, the IMPR modules, it was first used in the pharmaceutical market, and then at that time it was very expensive. So when we made all these LX module, we gain access to the power and also the microelectronics sector. And then after that, in 2004, we made the VNX modules that will bring down the costs even lower. So until this date, where we have the VNX Max, is up to 66 GPM of a nominal flow rate. So the cost per GPM is now very low, and then I think more and more people is going to accept CDI as an alternative to the mixed bed DI process. So for power generation, a high priority water that is required for the steam generation and for the boiler feed. Okay, that is because if it's not clean enough, all of the silica and the sodium is going to scale up the turbine, and then that is going to cause a lot of the repairs and the downtime. So as of now, in the Asia region, there is more and more power plants that is willing to switch to the CDI modules than to the conventional mixed bed modules. So for a boiler feed water, the typical of the requirements is 0.1 microsiemens, and it's also needs like less than 10 ppm of less than 10 ppb of the silica. So it's going to require a CDI feed of less than 200 ppb of a silica. There is sometimes a spec of a TOC that is less than 100 ppb. There could be other specifications like 2 to 3 ppb of a sodium and a chloride too. So if you want to achieve the silica, there has got to be control of the CO2. It can't be too high. And then in a lot of places where if the raw water source is not so good, it's like in Thailand or like in Philippines, there is a need for a 2-pass RO system. So why the power industry is going to choose CDI over the mixed bed modules is because in the first thing, there is no chemicals that is needed for the regeneration. There is less downtime. And on the performance wise, it's all very consistent. It's leak free. There is superior safety. In terms of the footprint, is much smaller. There is a lower cost to operate the modules. There is reduced labor. It's a continuous process. It's not a batch process like mixed bed. And then on the overall, there is a reduction of the environmental health and then also the safety risk. So CDI performance equals to consistent quality. Okay, unlike the mixed bed, that is going to be exhausted with time, and then it's going to require the chemical regeneration. And then there could be cases like poor regenerations in the mixed bed DI that is going to result in the leakage, and then there could be a shorter runtime. CDI modules, it can surpass the mixed bed DI in terms of the boron and also the silica removal, and then there's no spikes, there is no unexpected breakthrough. So now we talk about all of the products that we have. So this chart, it shows you all of our modules and then its flow range. So it means that for whatever flow rates that you want, we have the product to match your needs. So we have a wide range of the products. For the lab flow rates that is on the top right hand corner, that is called the Lab XT series. And then on the top left hand corner, we have the MX series that is for the low flow. And then after that, it is the LX and the VNX modules. That's for medium and high flow. And then to pair all this up, we also have, there is also some power components if you want to use. So for this LX series, is a medium flow power applications, is introduced in 2001. So in this series, we have 6 modules that's from 2 to 25 GPM of a flow rate. It's a fixed cell design where all of the compartments all have resins. Okay, it's being designed for the high pressure up to 100 psi. It's ideal for up to 100 GPM systems. So all the plumbing is very simple. There is only 4 plumbing connections, 2 inlet and 2 outlet. It's capable of continuous operation of up to 45 degrees Celsius, and it has a water recovery of up to 95%. So it means that there is only 5% of the water that is being wasted. For the VNX series, that is for the high flow applications, is introduced in 2004. So in this series, we have 9 modules that is ranging from 15 to 66 of GPM at a nominal flow rate. Is ideal for high flow systems of more than 100 GPM. Similar to the LX series, is also being designed for high pressure up to 100 psi. There is also 4 of the plumbing connections. There is high water recovery up to 95%. And And then the special thing for this VNX module is that there is a patented flex mount. There is a flex mount M blocks. So if you want to stack them up, you know, it is very possible. So for our VNX series, there are three kinds. There is one that is the high float industrial of up to 17 mega ohms of water. And then we also have another series that is for the high flow microelectronics up to 18 mega ohms of water that is capable of up to 99% recovery and also up to 99% of the boron removal. We also have another VNX series that is the higher feed challenge, so it can still make a very good quality of a water at a very poor feed conditions. So if the feed water is from 2 to 4 ppm of a feed water hardness and then up to 100 microsiemens FCE, it can still make a very good water. So in terms of our VNXs, it is a larger building block. So if you have a high flow system, you will need to purchase only a few modules. So in terms of like a system cost, there is a reduced piping cost, there's a reduced frame cost. It's much easier if you want to assemble it. There is fewer power supplies that is needed. So for the OEMs, okay, it makes the system is very simple to design, and then for the end users in terms of the footprint, it is all very, very small. So if you compare at the flow rate of about 150 meter cube per hour, the footprint of our VNX modules is like 1/3 the size of if you were to make use of the old LX modules. So for the VNX modules, there is only 4 piping connections. There are 2 inlets and 2 outlets. There is no separate electrode stream. So electrode compartment is part of the concentrate flow compartment. Okay, it is a downward flow that is co-current operation. So all the piping adapters is made of PVC. So all you need to do is to glue in the PVC pipe into it. So this slide, it tells you the piping connections and the plumbing ways. So the blue arrow is going to refer as the product, and then for the red arrow, it is the reject. So all these details, it can be found in the manual. For each of the VNX module, it comes with a junction box that is pre-wired. Okay, all of the wire connections is very simple. From the DC controller, you just simply have to wire in and screw tight. As for the convention, for the DC plus wire, it's red in color, and then for the DC minus, it's going to be black color. So one thing, if you want to take note of this box, is that for the IP rating is IP65. It is water resistance, but it is not waterproof. So more details, it can be found in the manual. So this slide, it tells you about the CDI feed water specifications. The typical feed water, it comes from a 2-pass RO permeate. It could be a 1-pass too. So the feed conductivity equivalent, that is the FCE, it should be less than 40 microsiemens, and it is a combination of the RO microsiemens and the CO2 and also the silica. For the max pressure, it has got to be less than 100 psi. In terms of the total chlorine, it has got to be less than 0.02 ppm. And then for silica and hardness, it has got to be less than 1 ppm. And then lastly, for the TOC, it has got to be less than 0.5 ppm. The typical of a product quality that is from the VNX module for a 2-pass RO system, it should be around 17 mega ohm at least. And then for the silica removal, it's around 95%. For the sodium and the chloride, is more than 99%. And then for our VNX modules, there is a minimum and a maximum flow rate. So if you are trying to do a CIP cleaning for one module, so the rest of the modules, you still can increase the flow rate to keep up with the production. And then to pair it up with our VNX modules, we have 2 of the power components. So all these are like the generation 3 power components. So on the left side, it's called the DCR components, and then on the right one, it is called the DC3. So the latest power components that is available now, it is the DC3 power component. Okay, there is no need for a transformer. So all you need is a factory power supply. There is 3-phase, 380 volts to 480 volts. And then all you have to do is to wire into the DC3, and then it's going to supply a DC output into the module. There is also a 4.3 inch of a touch panel display available. So it is fully functional with the DCR controller and also the DC3 power supply. So so one good thing on this touch panel display is that it can control up to 16 controllers at the same time. Okay, there is it also has a function if you want to make use of the Modbus feature. So now we compare the cost of a mixed bed DI and then for the CDI module. So the major cost for the mixed bed DI is like labor and resins and the chemicals and also the wastewater disposal. Whereas for the CDI components, it's a labor and module replacement after a few years. It could be after 3 to 4 years. And then there is also power. There is also some CIP cleaning. So mixed bed DI is a batch process, that is going to require the constant labor and also chemicals. Whereas for CDI, it's a constant production process. It's very minimum labor. All you need is just power. And then all you need to do is to record the daily data too. So a lot of the users is going to comment for the CDI module, there is less labor to operate. So all of the operators, they can multitask and do some other things too. In terms of the cost of the CDI that is versus the mixed bed DI, for the mixed bed DI, it is more expensive in terms of labor and chemicals and also the wastewater. And then in all, the operating cost savings, if you were to use the CDI, could be more than 50%. So in terms of the CDI, I think the major cost that has got to be factored into is only the modules only. So the typical lifespan of our CDI modules is from like 3 to 5 years. So if your pre-treatment is very good, it can last even longer than that. So for the end customer, the purchase price is important, but it is not the key factor. Okay, so they also look into the cost of operation that is also very important to them. So on top of all this mixed bed DI costs, all the mixed bed DI also have to consider other costs, is like employee safety and training and the safety showers, and it's like containment equipment, and it's also about the chemical storage and delivery too. So all these costs has got to be considered. In terms of floor space comparison, it is obvious that for CDI modules, it has more floor space savings as it's possible to stack up the modules. So if you have an existing mixed bed plant, and then if you want to increase the flow capacity, so if you were to use CDI module, it is one good way if you want to increase your plant capacity. So now we talk about our warranty and services and also the resources. So our CDI module, it comes with a 3-year prorated of the warranty. So if you install them and then if you run them as per specifications, and then if you try to log the data, you are in the warranty range, okay? And then at the same time, if you have a module that fails in the field, you can also ship back the module into USA, and then for the factory in the USA, they will test the modules and also open up the modules and try to find out the root cause failure. So and then after that, we will send you a report. So and then in the report, we are just going to tell you if you need to improve on your pre-treatment system or not. For our resources, we have a few. With the IMPR.com, there is also the newsletter. There is also technical support that is from Ted Kim and me. There is also technical training, at our factory. That is on the web training, and then all these resources we'll have in the website. There is also like a PNID drawings and the manuals. So all this information is going to help you install and use our CDI properly. For our newsletter, it's going to require a registration at the IMPR.com website. So once you register them, you will be automatically added into the distribution list, and then our product manager, Pat Basil, he's going to send you updates on it's like new products, updated of documents, and and it's also about the iPro software if there is any updates. So we have an online iPro software. You have got to register it if you want to use it. So this program, okay, all you have to do is to feed in the feed water guidelines. After that, you can choose the modules, and then it will roughly tell you its performance and also power consumption. So let's come to this example. Okay, so there's one power plant example. It's at the Colorado. So this is a Midwest of a US power company. So before, they were trying to make use of the old style pre-treatment, that is the cat iron and iron bed, and then after that is the mixed bed DI. After that, in the 1980s, in the 1990s, they upgraded into the RO system, and then after that they ran for 5 years, and then after that they upgraded all the mixed bed DI module into the VNX in 2007. So the main driver for all this is the need to reduce the operating costs, and then there is also a need to reduce the waste generation, expand the water system. So they chose our CDI modules. In terms of trying to use the old mixed bed modules, in a year, they would spend about 60,000 in terms of the chemicals. There is 2 regenerations per week, and then each time is about 4 to 5 hours. So when they switch to our CDI modules, in a year, they could be spending, it's about $2,000 in terms of power consumption. And then at the same time, the water system expanded at the same footprint level. There is also a reduce in terms of a labor cost. So the plant operator, he could multitask and do some other things. And then on top of that, there is consistent of a production rate and quality. So this is another example at the New York City. It's a power and district heating. So this is at the 34th Street Station. So below is some information on it. Is on RO and CDI since around 2005. There had been a few expansion over the years to increase its capacity, but however, the footprint it still stays the same. So the best way to do that is to take away the mixed bit and then put in the CDI modules. So at that time in 2005, it is the largest CDI system in the world. There are 10 skids of 45 LX30 modules. So at that time, it was the largest, but at this time in Asia, our largest system is in South Korea, and it's all in the Samsung group. So this is just a slide that is trying to show you the schematic layout of the system. It's a very low footprint. So now I'm going to show you the pictures across the power plants that is built across the Asia. So what you see over here is a power plant in Thailand. It's an RO and CDI combination. So as you can see, the footprint is all very, very small. And in terms of the CDI, it can be even smaller than the RO system. You know, it's possible to stack up the modules up high. And I think that is very good. So this is a power plant in the Philippines. So the pre-treatment system that is being used here is the UF, RO, and the CDI. So it is a very small in terms of a footprint. And then as you can see, for the piping material is made of the stainless steel and PVC. So a lot of piping it can be used. You know, if you want to use if you want to use a PVC or PP, or it could be PVDF, it could be stainless steel. So all can be used. It's just have got to see what is your you just have got to see what is your application. So this is a power plant in Singapore where it's going to make use of the LX modules and the RO modules. So as a rule of thumb, you know, if the flow rate is less than 100, if the flow rate is less than 100 of GPM, you can use the LX module. Okay, so if there's a flow rate of more than 100 GPM, I think VNX modules are more suitable. So this is another power plant in Thailand. So one thing to take note, you know, for our VNX module is that it is possible to stack up the modules one on top of each other. So if you have a site where there is a limited headspace, it is also possible to install our VNX modules in this way too. All right. So last but not the least, we have some time for questions and answers. I hope the viewers here, if there is any questions, could you please try to type it out on the control panel on your right hand side, and then I'll try to look into them. Is there any questions that is that all of the viewers have? Oh.
Yes.
Okay, Ted.
Yes. First of all, so really thank you for joining us. So I'm Ted Kim, based in Korea. So we are supporting technical issues about the CDI. So South Korea has a Korea Service Center. So if you have any question, any problems about the CDI, Korea Service Center team can support to you. So yeah. I've received several questions. So first question is CDI available in Southeast Asia? Pen,
is the CDI available in the Southeast Asia? Yes, it's definitely available. Our factory is based in the USA. All the modules is made in Tewksbury. So all of the modules that you have, it will be shipped out from the USA. And then I think soon in the future, we will also have a warehouse that is in Singapore. So in terms of a lead time, it's going to be shorter. Yeah.
Thank you. A second question is there an end date for the G2s to stop manufacturing them?
Okay. For our G2 controllers, it is the generation 2 G2 controllers. So it has been out since 2010. So it's been out for like around, I think maybe 7 years. And from 2017, we have the generation 3 controller. So in the factory, we still stock them. Okay. So our supplier is still making them. So if you want to buy them, it is still possible that you can buy from us. But in the future, we will expect like more and more people to change and upgrade the system into the DC3 controller. And then one good thing on the DC3 controller is that there is no need for the transformer. All right. But as of this time, we still sell the G2 controllers. There is no end date. I would say that it could still be available for the next 2 years. Okay. And then I think whether or not to end the G2 controller, we have got to see the demand. That is because in the next few years, there is going to be less and less people buying it. So I'm not sure if our supplier, it will still make them, but then we still keep quite a lot of stock from our supplier. So I think the answer is yes.
Thank you, Fan. So third is, what is the exposure time limit for high temp for VNX modules at 45 degrees?
Okay, so for the temperature limit of the 45 degrees, this is for the LX and VNX module. Well, I would say it shouldn't be too long. Okay, there should be some system safeguards to try to cut off the pump if the water temperature is too high. All right, so for a lot of cases in the water systems at the conductivity sensor, or it's like a resistivity sensor, there is a temperature monitoring. So it is possible that you can take that signal and tie in into the pump. So if the water temperature is too high, so let's say it could be for like around 10 minutes, and then it's going to trigger an alarm, and then it's going to cut off the feed water into the CDI modules. So the main reason for the temperature limit of the CDI module is just on the components. So if the water temperature is too high, it could melt the spacers, and then it's going to result in a leaking also. Yes. So I think the way to try to protect the CDI modules from the high water temperature, is through the system safeguards. You could just tie in a few interlocks. All right.
Thank you, Fan. Yep. Last questions. Whom do we connect with for a power project in Thailand?
In Thailand, okay, if you are the end user, we have a lot of the OEMs that is available in Thailand. I'm going to give you a few. I'm going to give you a few example of our key of the OEMs over there. So one OEM is like LPE, or it's like Goshukosan, and then there is also a few other smaller OEMs that could try to sell you the CDI modules and try to design for you. But if you want to know more, if you're not sure who are the contacts or who are the emails, you can always drop me an email after this, and then I can talk to you in more details. But if you're in Thailand, you should look for the Thailand of the OEMs.
Okay.
Any other
so
question?
Pen, thank you. Yeah, thank you. So returning to the question, one guest did so regarding the temperature. So it can handle 45 degrees, but only for a short period of time. What is the ideal operating max temp?
The operating temperature. Okay, so the most ideal operating temperature is for the warm water. Okay, as I speak about the feed water temperature in the earlier slides, is from 5 degrees until the 45 degrees. So the most optimum temperature is around 30 degrees to about 35 degrees. Okay, that is because, you know, if the water temperature is warmer, the electrical resistance of the module is much lower. So in terms, you know, if you compare to, if you were to operate a module at the winter time in Japan, it could be like 5 degrees Celsius. So it's going to result in a higher electrical resistance. So in short, at a lower temperature, you know, there is slightly higher power consumption. Yeah. So for the most optimum of the water, feed water temperature is about 25 to like around 35 degrees.
Thank you, Fan. So yeah, this is all I have. Yeah, thank you so much.
Okay. All right. So I think this is a very fruitful. This is a very fruitful presentation over here. So just before we end on this presentation, I just like to tell you that there is a power panel, there is a power brochure that you can download. So on the right hand side of the column, under the handouts, if you click on it, there is the power brochure for you to download. And then after this presentation, we will email you a copy of the presentation into the email. So for this last slide is my contact. If you like to, you can try to copy it down. And then if there's any further questions, please email them to me and then I will look into it. So thank you very much and just have a good day.